Our topic for today is how to solve any series and parallel circuit. In this lesson, we'll first discuss the individual between series and parallel circuits, using the most basic components, resistors and batteries, to show the difference between the two configurations. In series circuit, the current that flows through each of the components is the same, and the voltage across each circuit is the sum of individual voltage drop across each component. In parallel circuit, the voltage across each component is the same, and the total current is the sum of the currents flowing through each component. In sample problem number 1, if we have two resistors that are connected in series, what is the equivalent resistance? Let's say 10 ohm resistor plus 10 ohm resistor. The equivalent resistance is 20. Just simply add the two resistors. In problem number 2, we have two resistors connected in parallel. What is the equivalent resistance? Let's say that R1 and R2 are 4 ohms. Whenever you have two resistors connected in parallel, if they have the same value, the equivalent resistance is simply half of that value. So the equivalent resistance is 2. 1 over RT equals 1 over R1 plus 1 over R2 plus 1 over R3 and so on. And if we have two resistors connected in parallel, we have special formula. RT equals R1 times R2 over R1 plus R2. Then just simply substitute the value of the resistor to get the value of equivalent resistance. If we have two resistors that are connected in parallel that has the same value, the equivalent resistance is simply half of the value. In the example, we have two 4 ohm resistors that are connected in parallel. Then the half is 2 ohms. Just the same on 6 ohms resistor, the half is 3. And on the next equations, if we have 3 resistors that are connected in parallel with the same value, just simply divide the value of the resistor to the total number of resistors. In the example, the value of resistor is 6 ohms and the total number of resistors are 3. 6 divided by 3 equals 2. This is the same if you have 4, 5, or 10 resistors that are connected in parallel. With the same value, just simply divide the value of resistor to the number of resistor. In this problem, since R1 and R2 have the same value of 6 ohms, just simply get the half of the value of 6 ohms. Then redraw the circuit, and if you have two resistors that are connected in parallel, we have a special formula for that. The product divided by the sum, then substitute the value to get the equivalent resistance of 2.18 ohms. Here we have another example. Let's calculate the resistance. The R1 is 10 ohms, the R2 is 10 ohms, and the R3 is 15 ohms. You notice that the two resistors are connected in parallel. Then just simply get the half of it to have 5 ohms equivalent resistance. Then redraw the circuit and simplify. Add R3, which is 15, to have an equivalent resistance of 20 ohms. Our next example, it looked like it's hard to divide and conquer. But to be honest with you, this is very simple with a little tricks and techniques. First, the 3 9 ohms resistor are connected in parallel. In our previous example, if we have 3 resistors or more that are connected in parallel with the same value, just simply get the value of the resistor, then divide it with the total number of resistors, and the equivalent resistance is 3. Next, since the two 8 ohm resistors are the same value and connected in parallel, just simply get half of the value of 8 to get the equivalent resistance of 4 ohms. Then the circuit is now simplified series circuit, and in series circuit the formula is RT equals R1 plus R2 plus R3 plus R4 and so on. Then substitute the value. After that, just simply add the individual resistor to get the equivalent resistance of 16 ohms. In this example, it's gonna be harder, but by the technique of collapsing the circuit and then redraw to simplify, together we can do this. Let's start to attack resistor R9 and R10. Since these two resistors are connected in series, just simply add the value of resistor. R equivalent equals R9 plus R10, then substitute the value to the equivalent resistance of 30 ohms. Since the value of R9 and R10 is connected in parallel to R8 30 ohms and they are both the same value of 30 ohms, then simply get the half of the value, which is 15. Then redraw the circuit to simplify. After you redraw the circuit, you are going to analyze again how to collapse. Since the R equivalent and R7 are connected in series, you can add it to resistor. But you cannot add R6 because there is branching on R5. Just add the R equivalent and R7 to get the value of 20. After you get the answer, collapse the circuit and redraw and analyze again. In this new redrawn circuit, the R6 20 ohms and R equivalent to 20 ohms are connected in parallel. Given that R6 and R equivalent has the same value, just get the half of it to get the equivalent resistance of 10 ohms. After that, collapse the circuit and redraw again. In this new circuit, the R4, R5, and R equivalent are connected in series. Given that they are connected in series, just simply add a 3 resistor R4, R5, and R equivalent. Then substitute the value to have the equivalent resistance of 20 ohms. Collapse the circuit and redraw again to simplify. In the new redrawn circuit, R3 and R4 are connected in parallel with the same value. Just simply get the half of the value to have an equivalent resistance of 20 ohms. In the final circuit, the 3 resistor R1, R2, and R equivalent 5 are now simplified in a series circuit. Given that they are now in series, simply add the 3 resistors to get the value of 50 ohms. Back to the previous equation, find the total resistance and current. Given that our voltage is 60 volts, by using Ohm's law formula, I equals V over R, our voltage is 60 volts and total resistance is 50 ohms. The total current is 1.2 amperes.